Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will discuss about template matching in OpenCV. So first of all, what is template matching? So template matching is a method of searching and finding the location of a template image inside a larger image. In OpenCV, there is a method called matchTemplate for achieving this purpose. So let's get started and let's see an example about it. So I have this simple code which just loads this image, and let's see what this image looks like. So this is the image and this is the messy image, and what I want to do is I want to match the face template which I have, which looks like this, which is the smaller template which is also available inside this image. So this will act like a template for us, and we will try to find this template inside this larger image. So let's get started and let's see how we can search this template inside this larger image. So first of all, what we need to do is obviously we need to load this image and also load our template. So before loading our template image, I'm going to just convert my original image, which is the larger image, into the grayscale image. So I have declared this variable gray underscore image, and then I'm going to just say cv2.cvt color, which is going to convert my image img, and let's convert this image into cv2.color underscore bgr to gray. Now let's load our face image, which is called messy underscore face dot jpg. So I'm going to just change this name, messy underscore face dot jpg, and this will be our face image, or you can also say this is a template. And I'm going to also load this image as a grayscale image. So I'm going to just pass the second argument in the read method as 0, which is going to load this messy image as a grayscale image. Now in the next line, we will simply use this method which is called matchTemplate, and we are going to save it into some variable. So we can just say res is equal to cv2 dot match template, which is this method which takes few argument. First is our image, so I'm going to pass our grayscale image here. The second argument here will be the template which we are trying to search inside this image. So this will be our template. The third is the method. So the method can be several method. There are several methods available for the template matching. So I want to show you these method for the template matching. So you can see type of template matching operations, and there is separate formula involved in order to match that template inside that image. So for now we are going to use this method, which is tm underscore ccof underscore normed dot tm underscore ccof normed, which is this method. Now let's try to print this result, and let's see what is the content inside this result. So I'm going to just print the content inside this result which we got. So I'm going to run this code, and this image is loaded, but for now we are interested in this array matrix which you are seeing here. So you can see when you observe these values carefully, you will see all are relatively smaller values. So you can see 0.2, 0.2, almost every value is around until 0.3. So the maximum value I can see here is 0.3. So let me just show this image once again and the template also. So what this result contains is these all values, and there will be one value which contains the number, for example 0.8 or the brightest point. Okay, so if here this matrix contains a value which have the value 1, it is the brightest point, and it will be there inside this image after applying this match template method, which will be around this point, at which this template matches. So top left corner of this template. So at the point at which this left top corner of this image will match inside this large image, there will be a brightest point there, and that brightest point will be reflected inside this image in the form of this decimal number, and all the other values will be slightly darker values. Okay, so that's how from this matrix we will come to know the top left corner of the template inside this larger image. So now how can we filter out that value which is the brightest point inside this matrix? So all the points you can see looks like under 0.3, but there are some points here. You can see 3 dots, and there are thousands and thousands of values will be available here. All the values are not printed. Okay, so what we are going to do is we are going to try to find out the brightest point. So this we can find out with the numpy method. There is a method called where, using which we can find out or filter out those values which are greater than certain number. So I'm going to first of all declare a variable called threshold is equal to, I'm going to declare the value of threshold initially as 0.8, which will be relatively brighter point inside the matrix which we are getting using this result variable, right? And then there is a method called where, numpy where. So I'm going to declare once again loc variable and then np dot where method, and here we are going to pass our result which we got, and we are going to filter out using this expression. So this will be a boolean expression. So I'm going to just say give me all those values which are greater than or equal to the threshold inside this result matrix. Okay, so this where method is going to just evaluate this expression. Each and every value will be evaluated, and if this value inside the matrix is greater than 0.8, which is our threshold, then it's going to give those values to us. So let's print out those values after the filtering out of most of the values, and let's just print this loc variable also. So I'm going to run this code once again, and you can see here this is the matrix which we got. So you can see this is the array which we got. So still we can increase this threshold in order to find out only one point. So there are several points available here. So let's say I'm going to increase this value to 0.9, and let's run this code again, and you will see only 2 points, 85 and 220. So this is what we were expecting. So we wanted to find out this point which will be the brightest point inside this result matrix. So once we got the brightest point which will be around here, which will be the top left corner, as I said, of this template, and it will be located somewhere here in the original image, then we can draw the rectangle around this original image same as the size of this template. So this will be the easier task, because we already know the width and height of this template. We already know how to get the width and height of this template, and same size rectangle we just want to draw on this original image. So let's see how we can do this. So there is already a method, so I'm going to just declare two variables, width and height, and you already know the method. So template.shape is going to give you the shape of your image, right? So I'm going to just say template.shape, and then inside the square brackets we are going to just give 2 colons and -1. This means that we want to get the column and the rows value in the reverse order, so width and height. That's why I have given this -1 index here. Now in the next step, what we are going to do is we are going to just draw all the rectangles where the template is matched. So by seeing this template image and the original image, we know that there is only one messy face inside this image. But let's say there are several number of matched templates inside our original image. For that we need to iterate over the result which we got after applying the filter on the result. So for that we are going to just iterate over that result. In our case, as we know that there is only 1 point, so we don't even need to iterate over it. But if there are multiple number of matched templates, then this for loop will be handy. So for pt in your LOC variable, so we are going to just say zip, which is going to iterate over this LOC variable. So asterisk LOC, and then we are going to find out the width and height here also. So we are just reversing the x-axis and y-axis, right? So we are going to just say colon colon -1 here, and then once again inside this for loop, so cv2.rectangle method, and the first argument here will be our original image, because we want to draw the rectangle on the original image. The second argument will be the first point of the rectangle. So the first point will be this one pt, which we are getting using the LOC variable. So as you all know that the first point here will be the top left corner of the rectangle, and the second point here will be the bottom right corner. So how can we get the bottom right corner? We will get the bottom right corner using this pt variable, and then on the 0th index we are going to just add the width, comma, on the first index, so pt square bracket first, we are going to add the height. Okay, so essentially we have just found out the width and height of our template, and we are getting the second point using this addition on the first point, width and height. So it's going to give us this bottom right corner of this template or this point. So this is how we are getting our 2 points to draw the rectangle. Now the third and fourth variable will be simple, which are the color. So you can just say 0, 0, 255, which will be the green color, and the width, let's say 2 here. So we want to give the width 2 here. So let's run this code and let's see what happens. So I'm going to run this code, and you can see this red rectangle is drawn on the face of the Messi, and you can here also see this rectangle will match our template image. So whatever image is inside this rectangle will be exactly same as our template. And once again you can see the result. Let me explain this code once again. So if this point, this threshold will be 0.08, let's say. In the case of 0.09 threshold, we are only getting two values, this 85 and 220, right? That's why we are seeing the clear rectangle here. When we are giving the threshold 0.8 here, let's see what happens. So I'm going to run this code once again. You can see there will be this rectangle, but it will be much thicker. Why it's much thicker? Because we are getting several number of values, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are getting the 9 points on the x-axis and the y-axis. So this for loop will iterate 9 times, and this rectangle will be drawn 9 times on the image, and that's why this rectangle is much thicker. Let's just change this value to 0.9 once again, and you will see this rectangle is you know, the single rectangle. That's why it's much thinner, right? Now when you give this value, let's say we give the value 0.3, so most of the point, as you can see here, have the value 0.3, and when we run this code, you will see so many rectangles here. So that's why this thresholding is essential for us to find out the brightest point or the value which have the maximum value, right? So that's why we were filtering out these points and finding out the values more than 0.9 threshold. And about the methods, so let's try different methods. So let's try to give different methods here. These two methods behave a little bit differently. So we can start with this tmcorr normed, and we can apply it here, and it's going to give us this kind of result. You can see we are getting several points here after filtering. So let's try to increase this value to 0.95, and let's rerun this code, and let's see what happens. So now you are getting 4 values. You can also filter that out, let's say 0.99. now let's see what happens. So now you are getting only 2 values. Okay, so you need to try to change this value to the maximum point. So try to change this value, and you will get this kind of rectangle, only one rectangle. So every method is going to give you different result, and that's why you need to try all the result. Not all the result will give you the perfect rectangle or template matching, so you need to try different methods on your images. So this is how you can do template matching in OpenCV. I hope you've enjoyed this video, and I will see you in the next video.